Okay, Chapter 3 is on graphing, and in 3.1 we begin graphing using ordered pairs. So the first thing we have to make sure we understand is our coordinate plane. So we have a rectangular coordinate system. It's rectangular because it's only two dimensions. There's an x and there's a y. So it's like taking the number line for the x's and the number line for the y's and letting them meet in the middle at their zeros, which we call the origin. So that ordered pair is 0, 0, also called the origin. Okay? Our first quadrant is where x is positive as well as y is positive. And then our second quadrant, could we go counterclockwise, the third, as well as the fourth quadrant. So points to the right of the origin for x are positive, and to the left are negatives. Points above for y are positive, and points below are negative. Alright, so now that we're comfortable with our coordinate system, let's practice some problems from the chapter review on page 270. We're first going to start with number 7. So the instructions say, determine whether each ordered pair is a solution of the given equation. So I have the equation 3x minus y equals 12, and I want to know if the point 0, 4, as well as 4, 0, and negative 1, 15 are solutions. So let's do this one at a time. Let's start with 0, 4. Well, 0 is in the x position, and 4 is in the y position. So where I see an x, I'm going to put a 0, and where I see a y, I'm going to put a 4. And I'm going to use this equation, so I have 3 times 0 minus 4 equals 12. Well, 3 times 0 is 0 minus 4 equals negative 4, which does not equal 12. Therefore, 0, 4 is not a solution. Alright, now let's try 4, 0. So now we have 4's in the x position and 0's in the y. And we have 3 times 4 minus 0 equals 12. Well, 3 times 4 is 12, minus 0 is 12, which equals 12. So this one is a solution, this one is a no, and this one's a yes. And the last point we got to do is negative 1, 15. Now negative 1 is in the x position, and 15 is in the y, and we have 3 times negative 1 minus 15. Does that equal 12? Left off my question marks. Well, 3 times negative 1 minus 15 is negative 18, which does not equal 12, so this one is not a solution. So in order for it to be a solution, you want to plug in your x coordinate point, your x point as well as your y point. You're going to plug the x everywhere you see the x and plug the y everywhere you see the y. Your goal is to find out if the left side equals the right side. And if that's true, then yes, that point is a solution. Which means if you were to graph this line, all the points that work would be on the line. Basically, the line would go through those points. Alright, let's practice another problem. How about we work on graphing? So let's look at number 9. So it says, find 5 solutions of each equation. Organize your work in a table of values. Use the 5 solutions in the table to graph each equation. Alright, and the equation is y equals 1/2 x plus 1. Y equals 1/2 x plus 1. So I need to graph 5 solutions. So solutions is the same as saying points that go through, or points that are on the line. So I'm looking for x's and y's that work in this equation. Therefore, when I'm putting together my 5 solutions, I put together an x and y chart. Now x is the independent variable, which means you can choose it to be whoever you want it to be, and y is the dependent variable, which means it depends on x. Okay, so now let's pick some x's. So we're allowed to pick x, so let's start with 0, and then maybe -1, 1, 2, and -2. Alright, so I have y equals 1/2 times 0 plus 1, because remember you plug in the x to figure out what the y is. Well, 1/2 times 0 plus 1, that is 1. So I have the point 0, 1. X is 0, y is 1. Now I want to do y equals -1/2 times -1 plus 1. Let's see, that's 1/2 plus 1 is 3/2. So I have the point -1, 3/2. Good. Y equals, hey, how did I get negative? Oh, we made a mistake. I made a mistake. Let's go back a second. Shouldn't have been a negative there. Oh. Okay, y equals 1/2 times -1 plus 1 is 1/2. So I have the point -1, 1/2. Good. And y equals 1/2 times 1 plus 1. And you continue doing that, and you're going to find 5 points. So give me a second while I put mines together real quick. Alright, so I have now 5 points, which they wanted, and these points are solutions to the equation, which means if I plug them in, I will end up with a valid conclusion where the left side and the right side were equal, as we said over here. So now I want to graph this, so I'm going to graph this, and remember, how many points do I need to make a line? Yep, I only need 2 points to make a line. Therefore, I'm not going to graph all of these, because some of these are fractions, right? And it would be very hard for me to graph fractions accurately. So I'm going to graph 0, 1, and -2, 0. Well, 0, 1, 0 means I don't move in the x direction, I stay at the origin. And then 1 means go up 1. So there's the point 0, 1. Alright, and then the point -2, 0. Well, -2 means go to the left in the x direction, 1, 2. And then 0 means stay there. And then connect your connect your points. Put your arrows, it goes on forever, and that's the equation y equals 1/2 x plus 1.